they loan you out the saved assets, and as you pay back, the interests are distributed throughout members in a specific group. But it's kind of vague. I was still trying to structure out a way of creating something that is core and that tries to bring out the whole picture about the application. But anyway, that's it. I'm still trying to write out something that brings out how the whole app is going to work.
Okay, I think that would be a good idea, but there's something that I learned yesterday. We had some kind of pitch training. Like if you are
Yeah.
presenting your idea to people that you expect to help you in a certain way for you to implement your idea, there are things you should put in mind. And what I've really realized is that you need to be well versed with the problem that you're trying to address. And I'll be honest, personally, I think it's a good application of the technology if your purpose is to just learn how to implement blockchain technology into an idea, but maybe you should take some time and really evaluate the solution in this implementation because I see as if it's an iteration of what already exists. Yeah, that is my sentiment from what I've heard.
Okay.
And maybe also, sorry,
It's cool.
maybe also if I asked you right now, what is the relevance of blockchain technology in this idea? Do you think you would have the answer? Sorry if I sound very critical, and it's just an observation I'm making, just to maybe pick your mind to think about it more deeply. Otherwise, it would be a wonderful idea to implement. I would personally love to do it if I'm about learning technology.
I love the discussion, but I think, that would be, that is a very critical thing for now. Um, uh, One of the things I've seen, for example, in my journey is, innovation is only innovation if what you're talking about already exists in your environment. So I want to encourage us, even if something already exists. Actually, one of these days we're having a trust space, and one person was saying that actually now it's could be a better plan to build what is already there, because you already have a market. The idea is proven, and yeah, the market share is big. So Paul might be intimidated, but I think just building something for the first time, like just having something built out, however imperfect or perfect, that's a very huge step. Then it can be optimized. You can share, even just opening up a GitHub repository and then a markdown of your idea. You never know, because that's the way blockchains are built. Ethereum just have roadmaps and a bunch of Ethereum improvement proposals, and then maybe funds for their implementation, and just even sometimes there are no funds, but teams around the world, contribute to it. So I know that Po is moving at a good speed, which is good, but don't get intimidated. I think things will get clearer. Ronnie, isn't it? Yeah, Tracy, you're welcome. What are your thoughts? What are you planning to build? What do you want to, re rework on in the previous sessions? Yeah. It seems your volume is very low. Am I not the? I think I'm the only person who is not hearing her. Is it true? Is everyone hearing her?
Voice was a bit low.
Yeah, the voice is a bit low, so we are waiting for your input. Was it a marathon for you? And you are enjoying your pace? Yeah, any feedback is all right.
Hi everyone, hope you're fine. I'm actually enjoying and I've started liking everything. Not like in the beginning where everything seemed so new. At least I'm now seeing where I'm going. I'm looking forward on seeing projects being made. So what I've started, I want to implement. Yeah.
All right, that's good. Uh, yeah, only having that input, is a step ahead. Sometimes we don't realize, like, maybe some people are too, maybe we are too much into code, or we don't realize, like, even idea formation. But as you talk about something that you're thinking about, actually it becomes clearer. So yeah, every input counts. There's nothing that is vague. You can look at something and think things are vague, yet that same thing is being implemented by someone. So the idea is just come about something, implement it until maybe you need help or you can't implement it anymore. It could be like cutting across Web2 and Web3, anything. So ideas get clearer as you work on them, not as you think on them. So the more you write about it, maybe you've started by writing down and then you do some code implementations. Yeah. Any input? Omega Judith, you're welcome. Yes, Tracy.
Also the idea you introduced of like a recap on what we've studied. Sometimes the first time it is always not easy, but when you go back and look at what we covered again, maybe some of us can pick up from where we had lost from. Yeah.
All right. Yeah, thank you for that input. Yes, we are going to do our best and be deliberate about that. We are going to move a bit slow, a bit more considerate. Is to ensure that those who want to run fast can research into their ideas, and those of us who are maybe meeting these concepts for the first time, I can also have time to have recap. So in any case, if you have something that you feel at any time maybe you would want to have a recap on, or just something particular for you, feel free to put it in the Telegram or in our chat. Otherwise, yeah, we are really cooking around that to make sure that everyone gets the best out of it. Yes, Omega Judith. Did you join? And yeah, what's your feedback? What are you thinking about? I had Manuel talking about a native token. Tell us something. Okay. Yes.
Yeah, I was wondering if you can really tell us about some of the products being built by Ugandans. Those stories can be very interesting. Like recently, I saw this some the tutor.
All
I had
right.
never seen him anywhere before, and he's also some guy there. And even this former tutor of ours who unworld their stories, just how they learn, where they are from, stuff like that.
All right. That's incredible. Um, you are the one who's writing the stories now. Uh, that's the first statement. But what I can say is having like putting your idea or hinging your idea on just a problem is realistically enough, and that's the main thing I've seen. And I think sometime we shall bring these guys here. Maybe we could get time and have some the tutor here. We have builders in the field, Unreal Jova. But the thing is, actually, you are the one that is building that story now. And for me, my encouragement is don't see anything as too small. As long as you have one function on a product, you're already there. And I've seen this thing, we were talking about it during the that many people, as they are learning, they always have this thinking that what they have is already not enough. Yet, people who are having less are benefiting more than them. And we're just talking about how to put our content there, whether you're learning HTML. For example, if a PR of a company, goes on Twitter and let's say find someone who has been doing HTML for 30 days. This PR is not a technical guy. He's more inclined to hire that person thinking they know tech because they see his consistency and maybe he's writing some code, than someone who is probably learning back end and he knows a front end. Yet this maybe no one knows. So one of the things that I can say is yeah, your stories really count. I read your story. Your story was very impactful. For example, on LinkedIn, as you see, you would think buy me a coffee sort of DAP is very minimal, but actually that's something that you can pitch for people to send you tokens, like those who feel that you've done or you're doing a good impact, or even maybe you'd want to learn and you want to sort yourself. Like it's an entire product in itself, and the way you packaged it, that is good. So you're one of the people writing the stories now, but I think I will think about inviting these people. There's a lot that we are having inside yeah, central code, and I think with time we will have a look at them. Okay, Mr. Prime.
Yeah, thank you very much. So as Rian has been talking, something crossed my mind. Just like you said, we're the ones writing the stories, and I know we might all be thinking we're kind of like I don't know, say maybe very new to the Web3 space, but the Web3 space is relatively new, and there's still really many opportunities. And why I'm saying that is very soon we're going to be starting a podcast. So I think it is a platform for each of us to share our experiences, and particularly in the context of undermining projects because you personally think they're small. Guys, we are learning, and I believe it's wonderful if you can share the experiences you're having and your journey of learning. So if you can build small products and put them out for people to just to exhibit your experience, to exhibit your progress, I think it's wonderful. And this is what I've also learned, that as you master certain concepts, it is only natural that you start to undermine the value of them. You start to think they're very easy, and you assume that everyone else knows these things. So I think that's why we may each be thinking certain projects are not very important, that they are very trivial and they don't have relevance or value at all when people see them. But you'll be surprised how much value these things have when they're out in the market. Because Web3 is it's not an easy technology to understand. So do not undermine anything. Even something as simple, I was telling one of my people here, is that even something as simple as using a wallet, people do not know. So we may undermine a simple thing like making a tutorial on how to use MetaMask or use Trust Wallet, or just explaining the purpose of a public key. But these things are very new to people. So everything that you've learned up to this point is just as useful as you can put it out and get viewership for it. So please do not undermine anything you have.
Yes, yes. So that's great. It's something that I really have to remind us. I've seen very many builders, just putting their heads down, the fear of what they don't know. That's not it. And just know there are very many others that are willing to contribute on what you're doing. Just feel free, get out of the shell, and keep asking, keep contributing if you can. Just even contributing things like documentation will take you very far. Yeah, so nothing is small. I think we just need to repackage, gain that confidence, and then, yeah, become better. Because seriously, actually, in these 3 weeks, you may not realize, but we have been on a marathon. Our aim was to make sure that you people just open up to this field. Was to chase away the fear, so that whatever word that is talked about something, you know a clue about it. You're also inquisitive, but on the other hand, you've learned really a lot, like really a lot. And this field is new, so you are the guys who are in this field. Yeah, if you're somewhere, speak about what you know, speak about what you've learned, engage with us, with others, and yeah, let us know what you're building. You never know, whether we could contribute to it, whether we could push you. Um, Sometime when you're starting to, I think, campus, or when you've been in the school world, you're thinking my ideas are going to be stolen if I share. But when we reach at campus, those libraries are full of dissertations, full of ideas, but no implementation. So nothing is actually new. It's just that you're thinking about it maybe in a different route. What matters is something that has been implemented, even if a quarter of it has been implemented. Because if you show someone, that this is something I've been working on, I have this working, but this is not working, that's a conversation, than thinking I want to do something. I've seen those conversations where somebody says, but what is Web3? What can I do with it? I think the biggest conversation is what are the problems that are facing people, and then how can I tackle it? And as you tackle it, you will find that, oh, there is a technology that is blockchain that can help me better. That when you want to find the end in the blockchain, then it becomes somehow hard, and that's how most life face. I I reach to challenges. And even as we are studying Web3, some of the things, the application you're going to build in a Web3 system will be like Web2, actually fully Web2, and maybe you're accessing APIs, things like on and off ramps. You will not need to communicate with a MetaMask wallet. Maybe you just need someone to give you their address and then proof that they have transacted, and you store it in your own database. Like, that's entirely Web2, but then, it encompasses Web3, because you should know that this is a wallet address. Maybe you have a checker that the wallet address is correct and is of an EVM chain, but you're doing Web2. So also that obliqueness of when people start just to think that actually Web3 is an end in itself, and an engineer in the Web3 space, it's not entirely right. All these things communicate and work together. So just open up, try out things. If they fail, let us know on X. Let us know, let us, just post what you're doing, and the future is bright. Like, people are watching, and then you can also extrapolate your reality. Your reality is not only Uganda. Our reality in the Web3 space, one of the biggest issues it is solving is cross-border payment. The fact that you can send tokens to another person in another geolocation, and it reaches in very few seconds with the same transaction fees. If you vis-a-vis look at that, when you're sending money via MoneyGram, Visa, it takes weeks, and then you're chopped 30%, then someone has to sign things. This is already something that is being solved by the Web3, and maybe if you can, sort of bring it to a Web2 user, and maybe and make sure that this user does not abstract all the Web3 complexities, probably, or not abstract them. For example, maybe you have create a wallet and somebody sends money to their person, and then you map that wallet to a blockchain, and money is transacted through the blockchain, but the recipients are using Web2. These are ideas you can think about. And even just think about, you can start implementing something that you've seen, re-implement it, see if you can. Put it out there, like, I did this. Yeah, people can put, resources together, like use the internet, because the market we are looking at is Africa and the globe, including Uganda. So I think having that mindset and thinking is something that is good. Yeah. So I don't know who hasn't yet spoken. I'm not seeing Maria. I saw her on and she's gone. I would love to hear what her experience has been. Omega Judith, I think, is somewhere. Yeah, so probably today what we thought about, I think it was just a demand from the in-house team that we can work on demystifying Ethereum Virtual Machine again. And then the main issue was not actually talking about it, but it was about also introducing the issue of gas, because it's somehow attached. So Maria is back. You can tell us, anything, yeah.
Okay, since it's a week of presenting what ideas we have to build, uh, Manuel has already told us about the NFT marketplace, and so we came up with a group whereby each of us has to get a part, and then we shall integrate all the parts after. So me, I'm excited um, about what we want to handle. Yeah, the smart contracts part. So with doing so, I believe that I'm going to be learning more and more. I'll be exploring so many things. And I can't wait. And I also can't wait to look at the project. This, so it's Tampa West. There is, I expect much from it. So
All right, that's awesome. Yes, hopefully someone else is recording. We have also uploaded almost all the recordings of last week. So in case you need to recap on something, we are really working so hard to make sure that we improve on making sure we avail the information. It's not an easy task, since there are really very many hours, and just doing a small change, a small edit takes you lots of hours, rendering. So that baggage, but at least we have worked on all that info. I think there is only one video that has not yet been uploaded, and this is because the other uploading videos are really have not yet completed. But yes, feel free to check out some of the things. And I think we can get started today on a recap on demystifying Ethereum Virtual Machine. I see Judith is excited about it, and as always, So let me share my screen. Go Chrome. For this, I have two topics. Demystifying the Ethereum Virtual Machine, and they talk about gas, how to reduce the gas fee from this MetaMask. Let me first share. So sometime when you're making a transaction, get gas fees here, maybe you're writing a smart contract. So we want to see how to indeed reduce those gas fees and so on. So it's exciting. I have an NFT here on my Sepolia. I think I should gift someone some NFT. Okay. So I'm going to really do my best using this one, but if it really gives me a time, I will quit it. So most of the time, if we want to look at the Ethereum Virtual Machine itself, what is used to... So we can, if this is our EVM, really have to learn these things. Okay, I'm just going to use this thing that writes. So we said we could have our dApps here. This is ugly. Which is an application. It could be even a Web2 app or a hybrid between Web2 and Web3. Actually, most of the apps we think that are Web3 are just hybrids of Web2 and Web3. So the app could be talking to smart contracts, or could have a smart contract and a back end, or both. And then we can have the EVM, and then the Ethereum Virtual Machine, of course, will be communicating to nodes. Yeah, and based on what we have seen, all of this up to the, I think, the nodes. It's called is a P2P network, and yeah, and the way it exists is based on consensus. We are going to explain what consensus is. So now I'm getting used up to this thing. My line is crooked. So down here we can have the internet. So probably I'm going to be explaining many things, but let's first look at it. When you hear this is a decentralized network, what comes to your mind? Maybe if somebody can really explain that. So, or a blockchain network. What do you understand by a blockchain network? Let's feel free. Like today, I really want to lower down the intensity, make sure that we are getting at least that concept. What do you understand by it?
Okay, my own thinking of a decentralized network is a network that is connected, distributed across a number of people, but they all have equal rights and privileges.
All right, thank you for that input. It is something, yeah. I encourage us to be active also on one hand, because you can better get it. So mainly decentralized network, as I said, is just a group of nodes, each running a copy of the network. So by nodes, you can replace them with computers, maybe connected on the internet, and each running a copy of, let's say this system, maybe let's say this database. So I know we have cloud computing, but the biggest difference is if this is computer A and this is computer B and C and D. If this was a cloud, and maybe the reason for the cloud is for people in the location A to access the information quicker and people in the location B to access the information quicker based on that server, then just copies of this data are stored, but all these are using the same database. This data is talking the same database. There is no consensus. And what do I mean by consensus? Because they really don't agree what goes on around this network, around those networks, but they just make sure that the data is available wherever it is required, maybe based on that location. So what's the biggest difference between a cloud and blockchain sort of technology? So for blockchain technology, you'll have let me say decentralized network. You have A, B, C, and D having a copy of the network. I think this is supposed to be here. So having a copy, running a copy of the network, let me say running a copy of the database. But once a transaction or once data is added to this database, since everyone is independently running this database, and actually they are owning the database that they are running, yet it is supposed to be the same network. When somebody adds information to, let me say, this one's database, or when somebody makes a transaction, and that transaction is, for example, to be added on this one's database, it must also be added on this one's database, and also be added on this one's database, and added on this one's database, if I can say that. So a blockchain in essence is a set of nodes that are on the internet or on the network, where in case a transaction is added on one, or is added by one of, is received by one of the node, or someone adds something to the network, all these nodes must come to an agreement. That's the data that has been added is right, and after saying it is right, then each person running the node adds that copy to their data, so that the blockchain is in sync. So the means of agreement about adding new data to that blockchain is called consensus. So consensus is a set of rules. Is that something that is somehow relatable, or we need to repeat it? Because most of the time when you talk about these things, EVM, it's all about that. Maybe we can extrapolate it further, or let me read through my notes. Maybe people are somehow lost. Repeat from where? So let me repeat. A network is a set of connected computers, maybe communicating to each other. We say that a decentralized network is formed where different computers are running, different persons and entities are running nodes. Now, if you had one database, a central database, You could read and write to it as long as you have, let me say, the login details. Anyone with the login details can read and write to that same central server. Maybe the users are writing to that central server, maybe other people are writing to that central server. Yeah. So because it is one server, maybe it may become slow. All people accessing it from very far regions may receive this data slower. So you could choose to have this same central server, but distribute it over the cloud, or put copies of it on the cloud, and maybe you have in different regions, in region A, in region B, in region C. Yeah, in region A, B, and C. You could have probably cache of the server, and maybe that cache enables people who want to access this content from this server to access a copy of it from here quickly. And then people from region B and people from region C. So they're accessing the same data, but here it is faster and it's on a cloud. And what is the difference between the blockchain? In the blockchain, we have a network, and instead of having one server, every person who joins the network as a node runner gets a copy of the server, and instead, when someone writes to this server, their copies must be written to all the servers for these nodes or these connected computers to agree that actually something has been added to the network rightly. And by which mechanism does this get added on all those that are having a copy of the blockchain or are participating? It is added through a means called consensus mechanism. And consensus mechanism is simply a set of rules that these four servers are put together to use as an agreement that if data comes and I send you, probably it could be that if data is added onto the network and this, let me say server, it is called a node, receives it, then it will broadcast this data that has received to this computer, to this one, to this one, and all these computers can keep broadcasting. And if these computers, by those set of rules, agree that this data that has been added is correct and has been added correctly, and all of them had a copy of this data to their own database, then that has been added successfully to the blockchain. So that's the biggest difference between a blockchain and other networks, even distributed networks. So this sort of consensus mechanism is the means by which any computer can join the network and participate as part of those computers that are validating that actually data has been added, and that also it has been added rightly, and also keep a copy of the blockchain. So if this set of rules, which is called consensus mechanism, are publicly announced and anyone is left to, if their computers abide by this set of rules, then they can join the network, then that one is called a blockchain. So almost each blockchain has their set of rules to consider it to become a node runner or a validator on that blockchain, which constitutes a very big portion of what a blockchain is. Now from that we can set that as a background and explain the EVM. So I'm going to be going through the notes that I had so that I really become faster. And yeah, given that background, I think everything else is going to be easier. So Ethereum network exists solely for the purpose of keeping the single continuous uninterruptible and immutable operations of the state machine, that is the Ethereum blockchain. It is the environment in which all Ethereum accounts and smart contracts and data live. At any given block, Ethereum has one and only one of the global accepted states, the Ethereum Virtual Machine. So probably I've seen something that I can explain. Oh, it is 18. Want to be. So what makes a block? If this is block A, so this is block A. Maybe I can put it, let me put it here. And Control copy, Control B, Control V. So we have another block B and we have another block C. Yeah, so mainly the major thing that contains in a block is the block hash. You bear with me as I really get used to this thing. I have the block hash. Let's say the hash of current block. Please feel free to interject, feel free to interrupt, feel free to, give in something, like if you know how to explain something better. So hash of the current block. We have hash of the previous block. And the third one is hash is like a link. Okay, I'm going to explain what the hash is. And then it has the data. So a hash is when you get so for a hash is when you get data, and when you get data and you pass it through a hash function, then you get, I think this is far. So a hash is an hexadecimal number that looks like your wallet address, but it is a hash of data. So if I get like A, B, and C, and then pass it through a hash function, I'll get, if I get any data and pass it through the hash function, I'll get an exactly, okay, let me see if I can really have it. So there was a website where you could, I don't know that it's called block hash. There's someone know about it, where you put your digits and then it produces a hash function, a hash value. I've forgotten that website. Create a hash value from data input. So anyway, I've forgotten that. I think there is somewhere where I taught it and it has skipped my mind. But usually what happens, no matter the size of the data you have, let me say you have data of this size and you pass it through this hash function, you'll get, I think, maybe, let me say 20 characters hash value. So whether you have this amount of data or this small data, you get a hash value of 20 characters, but no hash value will be the same. And this hash value, the process is not irreversible. Why does the blockchain use such a mechanism? First is that it standardizes data. So no matter how big the data you've maybe probably deployed is, or you are saving, the blockchain will always save the hash. And that hash is small, like is always very small. So that's why blockchain stores hash. So you can see an example of hash from Etherscan. Please, if somebody comes across that website, you can put it in the link. If I don't come across it, I will post it in the Telegram, where you can play around with hashes, how to form blocks. So when you look, this is still. So when you look at these blocks, these are hash functions. So there's block height, transactions. These are the 16 transactions, and what you see is a transaction hash. So this transaction hash, okay, somebody so has brought. Thank you for providing it. Yeah, this will really solve my problems. Okay, yeah, thank you. So here you can have a block, here you have a hash. So this is a good website to demonstrate something. No matter the data you put, the output is of equal length. So even if I fill this input, that means that the blockchain is saving, yet each output will bring a different hash function. So the blockchain, instead of saving this too much data, because every person running a node must keep a copy of the blockchain, so we don't want to have a lot of data on the blockchain. They will instead, the blockchain will instead keep hash functions. I think, yeah. So, and all these three, this one will have the hash function of the previous block. That means that if I change the hash function of this block, this will have a different hash function, like it will get a different So the hash of the previous block is the hash current block. So if I change the hash of this one, maybe I tamper with this block. So maybe I want to remove one transaction, or I want to make sure that I stop one transaction from happening. Maybe I'm a part of those who are running the network. The only way to change it is when I change the hash function of this block, I have to change the hash function here and the hash function of all the current blocks. And in the way for me to do that, I need to have control over like more than 50% of these blocks, because the blockchain will agree that the transaction is true if more than, I think, 50% of the nodes running agree that the transaction has been verified to be true. So that's the only way. So maybe in case I need to inject data or what, and this is how the blockchain keeps its security. The hash function of the previous block here, since the beginning block is the genesis block, will be a predefined value like probably 000. Yeah. So these are I think the fundamental concepts forming the blockchain. And now let me now run fast through demystifying what's the Ethereum. So the way the EVM works, it works as a, I think I have my slides, as a state machine. If you have seen a state machine is like a machine where you input something and a given condition and then expect a given outcome. Okay, I think I'm going to miss many things, so let me just go through. So some basic understanding of, well, as we said, it is the environment in which all Ethereum accounts and smart contracts and data live. So at any given block, Ethereum has one and only one globally accepted state. The Ethereum Virtual Machine, which is the EVM, is what defines the rules for computing a new valid state from block to block. So prerequisites. So for you to know more, to be well conversant about the EVM, you should have some basic understanding of bytes, memory, and the stack. It is also helpful if you know something to do with base cryptography like hash functions. So we've explained something about hash functions, and these ones I was going to leave them out. Okay, so maybe we can start. What is memory? Computer memory stores information such as data and programs for immediate use in the computer. So the term memory is always synonymous with RAM and ROM and those things. So at least you should have understanding about it, because the EVM is storing states. So it will have concepts to do with memory. And the way most of the, okay, let's continue. The way we store most of the things is using an algorithm called a stack. And what is a stack? So in computer science, a stack is an abstract data type that serves as a collection of elements with the main operations of push and pop. So a stack is like when you put together plates. The analogy is putting together plates. When you say push, that means that you are adding an element on top of the stack, which is in this case putting a plate on top. And we say pop, it means removing the most recently added element. So there are other mechanisms like a heap, but the EVM mostly uses the stack, because we look at the newly created block and the hashes in it. Then we can only reverse it in that mechanism. Even one of the reasons we are reading this, there is now an argument in the Ethereum forum on reversing the transactions. It's called rolling back the virtual machine until the 1.4 billion people that for $1.4 billion that was stolen by social engineering by the Lazarus group from Bybit is recovered. So there is that argument there. But these are the same concepts. Okay. So the stack, we know if you've been studying computer science, it uses the last in, first out. And if you haven't studied computer science, it's also okay. You're now aware of it. Yeah, so it's something that the last thing that you add is the first that you remove. The last element that you add on top is the first to move. Whenever you hear about a stack, it's an analogous thing to putting together plates one at a time on top of another. If you want to remove those plates, you will remove the utmost first. And we've talked about the hash functions. So a cryptographic hash function is a hash algorithm um, that has special properties desirable for a cryptographic application. We've seen one of the functionalities of a hash, that no matter how huge the data is, a hash will have an output of the same let me say of the same bytes or bits. So that means that you are really compressing data, and then the blockchain stores those hash. So maybe the data can be indexed and stored somewhere else on decentralized storage systems or even centralized storage systems. But since we are leveraging that the blockchain, then those hash can point to where that data has been stored. Okay, so now let's go to what is a state machine. A state machine excuse me. Sorry for that time. So we see blockchains like Bitcoin are often described as distributed ledgers, which enable the existence of decentralized currency using fundamental tools of cryptography. So we all know Bitcoin is a distributed ledger. So in this case, a cryptocurrency is like a normal currency because of the rules which govern what one can and cannot do to modify the ledger. So these rules underpin all transactions that take place on a network, for example, the Bitcoin network, and similar to all other blockchains. So while Ethereum also has its native cryptocurrency ETH, it also enables a much more powerful function that we have seen, smart contracts. Yeah. Okay. All right. So one of the biggest difference between the Bitcoin and Ethereum is that though Bitcoin is used for transacting finance, it is used as the gold standard. Ethereum is currently shifting to that. Ethereum introduces programmability onto such a ledger by introducing smart contracts. So Bitcoin doesn't have smart contract programmability on it, though of recently there have been very many researches around unlocking the liquidity that is on Bitcoin, some through layer 2s on Bitcoin like Lightning Network and the Babylon testnet and mainnet. But yes, Ethereum was created with programmability in mind, whereby users and builders can build their own apps on top of the blockchain natively. And the mechanism by which this was achieved is through a state machine. A state machine is essentially any machine that can change from one state to another in response to certain inputs. Yeah, an example of a simple state machine is buying soda machine. So that means that if I have state A, let me say the machine is locked, and then I give an input, which is I input a coin, then the machine will give me a soda. And then if I open it again, I can open the door to pick the soda, but then if I try to push the lock again, it is locked. And then I have to put in the coin again, and that's how a state machine works. In this analogy, we can compare such a machine to having the blockchain as the state machine and having a set of inputs as a smart contract, which will prompt the blockchain to reach a certain state or to do certain things. So a smart contract should not confuse with the name smart contract. It is actually just a set of rules that a builder determines in order to achieve a certain output. So we can, I think, any questions? Any questions? Should I pause? Should I continue? Yes, Mr. Ron.
You have talked about BTC being built without programmability in mind, and then you talked about a layer 2. How is it possible for Bitcoin to have a layer 2, the Lightning Network, you have said? Yet it's not programmable.
All right. So one of the issues that the Lightning Network is facing is security. So Lightning Network does its own mechanism of reaching consensus, or let me say of proving that the transactions are right without any connection to the Bitcoin. But most of what they have is they just have liquidity that is staked on the Bitcoin network, that acts as a proof to the clients that in any case, if the proofs and the transactions that we are carrying out on the Lightning Network go wrong, your liquidity is safe on the Bitcoin network. So they have just a proof of liquidity. And like there have been very many issues. For example, I think we shall see it forward, but most of what happens with layer 2s is that they have a smart contract on the Ethereum network and a communicating smart contract on layer 2 that will send maybe probably these transactions, and the Ethereum network will verify. So that has been the biggest issue with the Bitcoin network. So people are totally just building their own blockchains. I think it is getting improved because there is an OP-cut proposal by the Bitcoin community to bring like proofs on the Bitcoin network. So that will enable like having proofs on the Bitcoin network of correct transactions. I don't know if I've answered or I've talked a lot, but somebody can.
So you are saying the Lightning Network, which is the so-called the layer 2 on Bitcoin, is a completely different Ethereum, some project built on, because you have talked about a contract on Ethereum again.
No.
I'm not understanding how is it associated with BTC. I thought
No.
like
Like
layer 2s are built on top.
Like Lightning Network is not an Ethereum network or an Ethereum layer 2. The same way you can see a layer 2 on Ethereum. Let me give an example. For example, Optimism. Lightning Network is a layer 2 on Bitcoin. But the issue, so I was trying to highlight the issue it is facing on proving transactions on the Bitcoin network. That it is supposed to reach consensus, for example, to ensure that the transactions that are carried on it are right. Of course, the Lightning Network is very fast, but it's supposed to send a proof to the Bitcoin network of how it has carried out these transactions, and that proof must be in agreement with how Bitcoin network proves transactions. And that's where the issue comes in. Since Bitcoin network is just a ledger, it doesn't have the opening for it to prove whether the transactions that have been carried out on the Lightning Network are true. So the last time I researched on the Lightning Network, which is not, of course, very far, the Lightning Network had just reserves on the Bitcoin network that could provide confidence to the users of the Lightning Network that their funds are safe. There are also other like layer 2s on Bitcoin that will mint a one-on-one token on their networks compared to the liquidity that they have in the Bitcoin network. Yes, but of recent, they are due to the improvements that have been happening in Ethereum. The Bitcoin network is trying to improve that so that it can bring programmability to the Bitcoin, because Bitcoin doesn't have smart contracts. So people build just their own network and then sort of have a way to prove to the community that your funds are safe. Have I confused you more? So the Lightning Network is entirely built for people who are transacting the Bitcoin tokens. Yeah.
I think I had got it, but then you introduced a new question. You have talked about these EVM chains that create like BTC one-to-one trading, yeah? And then you said they have a way of proving that how do they do it? How do you know that the wallet address, maybe I'm showing you, I don't have access to those tokens? How do I prove to the people that I actually have these tokens on the BTC? Do I
So
provide the address?
there are very many mechanisms. I think those ones you'll research, but one is proof of reserve. So a proof of reserve is anyone maybe could go to a reserve and request for proof of reserve in the blockchain of the funds that someone has. For example, one of the companies that has proof of reserves is Binance. I think you can go the Binance Smart Chain and query for the proof of the reserves or the funds that Binance has. It can be something that you can research about, because those are layer 2s in the Bitcoin network. You can also research on other innovations like STA, like stacks. So I think it's called stacks network. Like these are all innovations. You can also actually come up with an innovation. So the leading Bitcoin L2 smart contract. So this stacks ecosystem is trying to bring smart contracts to Bitcoin. Yeah, so it's all about innovation. It's all about innovation. But I also want to open your mind that also the Bitcoin community is innovating, and you can innovate either way. Well, I think they have a one-on-one token with, so that means that for every token that they mint, they have locked an equivalent in amount on the Bitcoin network. It's BTC. Anyway, I think I can stop there on answering that question so that we take on this journey. But you can still ask if you still have some questions. So on Monday we looked at something like this, and we are going to look at it again. I think this is like the most simplistic way of showing a blockchain, that given an old valid state S. So I have my blockchain is at that state, and a new input of valid transactions T. You see, I'm making valid. So whenever I put the word valid, it means that they have been proven to be valid. Okay. Yeah, so given those two conditions, the state transaction function Y can go from the old state, this S, to a new state S complement. So in this factor, I want to reach this new state. I'll write a smart contract, and it will be a set of rules which when I transact it, or when I put it on a blockchain, and it will move this state from the old state S to a new state S complement. That's actually the reality of what happens behind a blockchain scene. Though on a high level the smart contract is doing what you have told it to do, or what the code is commanding it to do, that is essentially what it is doing down the road. The set of those transactions they come up to such a thing, and then most of those transactions create a block. From those transactions we get their hash functions, and a collection of those hash functions creates a block, and then a new block is generated through that same mechanism. So let's look at OP codes. I thought this topic is going to be quick, and we'll look at gas. It seems people are losing gas. Opcodes. The EVM itself behaves as a stack machine with a maximum depth of 1024 items on the stack. So collection of stacks with 124 items on the stack. Okay. Each item in that stack is a 256-bit word or 32-byte word. Let me see if these things work. So we are sort of like stacking 1024-bit elements, and each is a 256-bit operate bit. So like and each element is 256-bit element. So these are 32 so this is how the EVM behaves. So during the execution of a transaction, the EVM maintains a temporary memory which does not persist between transactions. When a new transaction starts being executed, the temporary memory is reset. Okay, I think there is a lot of noise. Okay, so the temporary memory is reset. Yeah, smart contracts, however, do maintain their own state on the blockchain. This state is commonly referred to as the EVM storage during transaction execution. So storage is long-term memory and the transaction memory is short-term memory. So if you are writing a smart contract, I think I can give an example. So most of the time when we are writing smart contracts, we have to put these into consideration, because whatever identifier, whether public, whether internal, external, it has like an effect on the gas. And if you're writing, for example, permanently to the blockchain storage, you'll incur more gas than writing temporarily to the blockchain, so that the storage is accommodated during the transaction. And I wanted to show a difference. But for example, when you're using public, the data is reading both internally in that smart contract and externally from external callers. So it takes on the storage. Whenever a function is reading in that same internal smart contract, that data is stored internally, like permanent, on a permanent storage. Yet if you just changed public and maybe the function of the smart contract was could be completed well with just external, I think, let me illustrate it. Function receive okay. So let me say contract. I'm just getting this off it, but hopefully it will showcase. So external. So here let me say function. External receipt. So instead of having it public, I'm going to have it external payable. Let me warning, this function is named receive, but it's not the receive function. This is not a function, it is a contract. So I've written two contracts in the same. I think the warnings are fine. So here, if I'm deploy, I can, let me first deploy store me. I think the computer making the echo is really. So yes, this transaction has been complete. And so if I show this, you will see gas is 85058. For this function, let me just, for this contract. But if I also control save, I deploy, so here I can deploy, and I deploy the receive external, deploying, it has finished. You see that the gases okay, here let me receipt. So 8082. Okay. So this is a different gas, 85058 and 85072. So let me remove first this contract and save again, and then deploy. This time I'm choosing, it is only store me. Deploy. So we have 85072 gas. So here let me I don't know why I went this route, but let me deploy. transaction cost, and transaction cost 739.75. Yeah, it's almost the same. It's the same actually. Okay. So I'll come back to it when I'm into gas. But one of the things you can see is just with changing a few things, you can have 850-72 as gas and 850-58 as gas. I think the reason I went there was because of the opcodes. So opcodes, when our code is compiled, as we saw last time, or not even last time, as we are seeing now, where is here? So our code is compiled into what we call a bytecode. I don't know how to remove this, but yes, this is bytecode, and let me put it somewhere here. The txt, and and this is okay, let me bring ABI because ABI is quickly understandable. So the bytecode is what communicates to the EVM, and they are a set of characters that this is the bytecode. So the opcodes are just set of characters that look like this. So copy bytecode, okay. Control V. So it's like set of characters 6080, and this is the last implementation of our code, and this is what the EVM understands. So what we write as smart contracts compiles into bytecode that is compiled into opcodes, which talks to the Ethereum Virtual Machine. Now these opcodes they're the ones used to generate the gas of your smart contract. So sometimes when you're deploying a smart contract, let me take an example of this. We still have our smart contract. I think we are going so much into gas. So if I choose injected provider, and yes, my MetaMask is there. I don't use this for writing. So let me say I have this smart contract. So control save. This is the only smart contract I have. It seems to be big. Okay. I can look and see if I have other smart contracts. If not, let me go with this. Reload. So control save. Okay, it's taking its time. Just create a new smart contract. So here I can say I have okay, it has finished compiling. So if I try to deploy this address of the initial owner, let me copy this address just first. And then I click deploy. I'm waiting for the MetaMask pop-up. Oh, sorry, I had to put injected provider. And yes, deploy. Okay, so on this MetaMask that comes up, there is network fee, and also there is a fee. So there is network fee, which is 0.01. This is of course this Sepolia, so it's a layer 2. There is maximum fee, which is this, nonce 30 seconds, and then the data. So this data is as so this is the opcode of the smart contract, and this is also responsible for the weight of my smart contract, which will transfer into the entire amount of gas fee I will pay. So let me probably change this to Sepolia ETH, which makes everything a bit more clear. So that's why you have to have Sepolia ETH, yes. You have to be very cautious of the gas that you're spending at every go, like what the smart contract you're writing, how much gas it is consuming, because if it consumes more gas also, the people using the smart contract will also incur more gas. Then it will just propel people away from using your smart contract. Injected provider, should I? So here, gas estimation error, send transaction. So when you look at this is Sepolia ETH. It's already telling me my gas is 172.96 ETH, nonce 6, and then the data in hexadecimals. So this is like exorbitant gas, but we are going to see all these reasons. So let me just read through the opcodes and then have a break and come back to the topic of gas. So during the execution of a transaction, the EVM maintains a temporary memory which does not persist between transactions. When a new transaction starts being executed, the temporary memory is reset. Smart contracts, however, we've talked that they do maintain their own state on the blockchain. This is commonly referred to as the EVM storage during transaction execution, i.e. storage long-term memory of smart contracts, and the memory is short-term memory within the EVM. So the EVM has logic present that allows it to execute certain EVM opcodes, basic operations that can be executed on the stored data, such as add, sub, mul, div. So these are like statements that can be executed on the EVM, but each of these also has a corresponding gas, as we shall be seeing, balance, block hash, and so many. So later we shall realize that the way this does is, for example, if your smart contract has add, it will take on it is an opcode that will take its own gas, which is predetermined. Maybe it has a balance of, so maybe the balance of can be like 700 gas. Yeah, so and then all these are added up and they form the cost of your smart contract. Yes.
Yeah, my question is, if I had all these different functions in my smart contract, and I was trying to deploy it on maybe ETH mainnet, and then after evaluation of my gas, I really see it's going to be expensive to maintain it on the ETH mainnet. Would a deployment on a different, maybe EVM compatible chain require me to pay the same gas, or does it depend on the chain for the gas fees?
So
In the case
the
where I haven't changed any function, smart contract.
so the gas fees depend on the chain. Yeah, we are going to actually see the reason why gas fees are very high on Ethereum. Yeah, but it's dependent on the chain. Okay. So I think for the opcodes, I can stop on that. Probably I need to show. I had some thing that had opcodes. Yeah, it is this. Not really. So there is a chart with opcodes and their corresponding meaning. Let me see if I can get it here. Someone sent it in a group. So I think I shared it last time, but where you have an opcode, what it means, multiplication. I think it is ethervm.io. So here you have a list of the opcodes, and yeah. So here you can have the mnemonic, the stack input and stack output. And when you see a digit like this one, it means 60 is an opcode. So the EVM has compiled to 60, 80, 60, 40. And from this same chart, this way I have been. From this same chart, you can know that 60 stands for 3, 4, 5. For the push, so we are pushing uint 8 onto the stack, purchase a 1 byte value onto the stack. And what we are going to see next is the gas. So you will realize that each opcode corresponds for a given gas, and then gas fees are computed from that. So this is like one of the biggest precautions for you to take precaution about when you're writing smart contracts. It's not just only about something doing what you want to do, because that's the best thing in Web2. It's also something that is being optimized for finances. Then the other thing is whatever like is being implemented on the Ethereum Virtual Machine is gotten through EIPs. So EIPs are Ethereum Improvement Proposals, which are voted on and then passed and then implemented by builders. So you could be in those forums, and we are going to see more of that, I think. So allow us, let's have time to have a refresher. I think by 1910 or 1915, we shall look at gas briefly and then stop at that. Any input? Or you can start. Okay, we are 1 minute to time. All right, so it's exactly 15 minutes past. And yes, let's start gas. So gas is one of the most important fundamental aspects of understanding Ethereum blockchain. So I think these links, you can really get them from your friends or somewhere like when you search online, but I believe many of us have them. Many of us have them. So yes, let's start with this topic called gas. I'm looking for so this is where I was, like in everything, understanding, I think gas is one of the most important thing about Ethereum. One of them, not the most, but one of them. So gas is the fuel that allows the Ethereum network to operate. So in the same way that a car needs gasoline to run, gas is a requirement for Ethereum to operate. So we're going to look at mainly three things. One is how a transactions calculated, transaction fees calculated. So I want to know how come, like sometimes we have exorbitant transaction fees and sometimes we have low ones. So how much ETH do you need to pay for gas? And then today we can look at why some transactions more expensive than others. And then we can also look at why do gas fees exist. So we are going to dwell at these four important questions. So for us to answer this question, we must look at the two states of the blockchain that changed gas. One was the pre-London upgrade and the post-London upgrade. So what was the upgrade? So there is a time when the blockchain underwent through an upgrade called the London upgrade in August 2021. And who of us knows what an upgrade is or a hard fork in Ethereum is? Or is this our first time to hear about it? So does Maria know about it? Yes.
Okay, I just know about the upgrades, but
Okay.
in my own understanding, but this is the first time to know about the London upgrade.
Okay, so what do you know about the upgrade?
Okay, it's like if there is an existence of a version, then uh, maybe another version is brought up in place. So they are upgrading from this version to the other. It's like they're improving value or something.
All right, thank you for that. Any other person? So yes, an upgrade is simply a fork in the Ethereum network. So as we saw that the blockchain cannot be tampered with, and in case someone changes the hash of or some transaction in a given block, like all the consequent blocks must be changed, or else that transaction will be considered an invalid transaction. So an upgrade happens when something fundamentally must change in the way the blockchain is. So the first upgrade, one of the upgrades that happened so much was the upgrade when Ethereum suffered an entrance attack and over 60% of the treasury was drained. So what Ethereum team did is to have a rollback and then create a fork out of Ethereum. So the main Ethereum network that was running the normal blocks was left, and then the new forked version was taken as the Ethereum version. So there was an upgrade when Ethereum was transitioning from proof of work, because at first Ethereum was proof of work to proof of stake. So there was also an upgrade in 2021 called the London upgrade. And in this London upgrade, Ethereum wanted to standardize gas. So history of forks on Ethereum. Tim Baker. Okay, this is good. So Tim Baker. So yeah, there were 5 EIP stands for Ethereum Improvement Proposals that were part of the London upgrade, and I encourage each one of us to go and read about it or watch a video about it, and also watch a video about upgrades. So whatever is going to be done on Ethereum must first be proposed through the EIP or Ethereum Improvement Proposals. And if you want to be like a contributor to the Ethereum network, the Ethereum network itself, not a layer 2, but to the core infrastructure, you could be one of those that really participate in these, EIPs, discuss around it, like engage in their discussions. I think there is the Ethereum forum, and yes, it is interesting and fun, and maybe probably there you can create a career in that. Yeah, so for now, the London upgrade happened in 2022 to stabilize some features of the gas fees that was happening. So we are going to look at the pre-London upgrade and how gas was consumed, and then look at the post-London upgrade, which happened in 2021, August, yes. So in the pre-London upgrade, it's good to understand and easy to wrap around how gas generally operated. So what exactly you could say is this gas? Just like seconds are a unit of meters, so gas by itself is a unit of computation on the Ethereum network. And it is very important to note this, that gas is a unit of computation, not ETH, because whenever you are making a transaction, maybe you are paying 0.2 something ETH, but that comes fundamentally from gas. So gas itself is a unit of computation on the Ethereum network. So the gas unit is used to measure the amount of computation effort required to execute a transaction on Ethereum. So since each transaction requires some computation resource to execute, it requires a fee commonly called gas fees. So there's a difference between gas and gas fees. So we are used to gas fees, but gas is a unit of computation. So sometimes you can call this as transaction fees. Yeah. So we can take a note that generally when someone says gas, they refer to gas fees, not the unit itself. However, for the purpose of this session, we'll be technically correct and say gas when referring to the unit, and gas fees when referring to the fees in Ether. So this is what you see on your MetaMask when you're deploying or sending as gas fees. So for this as a unit of computation, we shall take gas and gas fees as the fees themselves in Ether or ETH. So let's look at how gas was being calculated in the pre-London upgrade. So before the London upgrade, and don't be scared by the name London upgrade, it was simply implementation of 5 EIPs, Ethereum improvement proposals, that made sure that the gas and some other things in the Ethereum network are optimized, and yeah. So gas fee calculation. So pre-London, for you to get gas fees to spend, it was similar to gas spent and multiplied by the gas price. So, and what is gas spent? So this is the total amount. Of gas. So the units for gas is gas units. That was used to execute a transaction. This is not the gas fees, but this is the gas spent, because we said it is the gas spent times the gas price, and then the gas price is the amount of ether you are willing to pay per gas unit of execution. Amount of ether and so one is willing to pay per gas unit of execution. All right. So the gas unit was measured in Gwei, and 1 Gwei or Giwei is equivalent to 10 power negative 9 ETH. So that means that 1 ether or 1 ETH is the same as to 10 power 9 ETH. So instead of saying your gas price is probably this ETH, or you can exchange it with Gray. Yeah. And what is one way? So a way is the smallest unit of ether. Smallest unit of ether. and 1 way is equivalent to 10 power negative 18 ether. So let's take a mathematical scenario. So suppose Emma wanted to send probably 1 ETH to Charles, wanted to send 1 ETH, wanted to send let me say ETH to Charles, and wanted him to receive 1 ETH. So how much would he have to say? How much would he have to send? Assuming the gas price is 200 Gwei. Maybe we can do that, and I'm waiting for the answer. Answer should be in ETH. Yes, is there someone attempting the question? Okay, that is good. Let me wait for those attempting. So I'm waiting for an answer. Manuel Ayatit. Okay, the question is here. Who else is attempting? If you have gotten an answer in ETH, you can let us know. You can unmute. I'm fine. How are you? Right now, let me check on this number. Okay, let me. Yes, Maria.
Okay, according to the question, uh, they're asking us how much we would have to send, assuming the gas price is 200 gray. We know that 1 gray is equal to 10 exponent negative 9 ways. So what we do, we're going to get the 200 gray, the 200 times the approximation in the S, which is the 10 exponent negative 9. So the answer is 0.00002, which is 2 exponent negative 7.
Okay. So um, maybe look at the gas fee. So I think you've either calculated the gas spent, but for him to send, he pays in gas fees, and this is the.
Sorry, Leon.
Yes.
Perhaps I would seek some clarity because we have the price of gas, the gas price, but we don't know how many computations, how much computation power it would require in terms of gas to execute that transaction.
I think the question is self-explanatory. So probably if you wanted one ETH to reach him, so the gas price from here, you can get the gas fees. So gas fees will be the same as gas spent times gas price, and we know that the gas so the gas price is 200 way, and we don't know the gas that will be required to so yes, you were right on the clarity on that, I think. Gas to be spent, okay, the reason I didn't put it is because it is a constant unit, so the gas unit on the blockchain is always 21,000. But let me put it for you, because you had to research it out and find it because it's a constant. Yeah, I think now we can get the gas and then add it to the amount of ether, so that, yes, Prime.
Are these like 20,000 arbitrary units, or there are 20,000 computations. Just trying to get an interpretation of what it would actually mean in terms of computing power.
This is gas. It has nothing to do with computing power. One of the reasons gas was introduced to the blockchain is to make sure that things like distributed denial of attack on the blockchain that could slow the blockchain are minimized, because every time you write to the blockchain, you're actually losing money. So I may not be informed about the computing power, but pre-London upgrade this where the standard units of gas for every transactions you had to make. And by transaction I mean sending and receiving. Perhaps we can continue, and then as you're looking for the answer, I think it has been made a bit simpler. So my intention was to see someone who has researched something about it, but it seems it was far-fetched. So maybe you could have questions how the gas price is often sent to 200 Gwei, because at least for this it's a unit of gas. Yeah, one of the factors that sets this gas to these amounts is the incentive given to the validators. So you find out that transactions with higher gas price have higher priority to be included in the block, as miners receive higher tip for mining those first. So gas price therefore basically works like an open auction or a sort of a bribe to miners. Whoever is willing to pay the higher price or higher bribe to the miners gets their transactions included faster than the lower priced ones. So sometimes you could be making, for example, deploying a smart contract, and then on the gas they say speed up, and then it has a higher gas fee. And that's an incentive for miners to really work on yours fast. So we had wallets like MetaMask that provide reasonable estimates for gas prices based on the current network conditions for transactions to be executed. Therefore, most users don't need to touch the gas price values themselves, though you can enable modification through MetaMask settings. So actually you can really do a lot of play around offs with your gas in the MetaMask settings. So let's look at the gas cost calculation. When a smart contract is compiled into bytecode, it is compiled down to opcodes before deployment to the Ethereum network. So these are simple operations that can run directly on the Ethereum Virtual Machine. They are analogous to basic operations that run directly on the Intel CPUs. So things like div, mul for multiplication, sub for subtraction, SA3, balance of. These are opcodes that have an exact equity or something equal in terms of gas. For example, you'll find that wherever there is an add, the gas unit is 4 or something. Yeah. So each opcode has a fixed gas costs, and the gas costs of a specific function within the smart contract is the sum of all the gas costs of all its opcodes. Okay, are we following? Are we following? All things are becoming a bit tough. Do we need a break? So what does that mean? Because everything is a thumbs up.
We could take a break for like a minute or two, but trying to internalize the concept of gas price and gas spent.
Okay. I was also thinking maybe I can just pass through and leave it as a research. How is that? Um, are we done? Are we not yet done? Are we still working?
We are done.
Okay. So as I was saying that each opcode has a fixed gas cost. The gas cost of a specific function within the smart contract is the sum of the gas costs of all its opcodes. So here on this GitHub repository, I've sent the link in the group. You can see the opcode, the name, for example, add. It it is 0x01, and it is an addition operator, and the gas of that opcode is 3. So that means that actually if you know the gas, you could literally write your smart contract in bytecode. Or you could be one of the best hackers, those who see vulnerabilities and fix them, because all the smart contracts are compiled into opcodes. I wanted to see smart contracts here. So 110 contract interactions. This is a smart contract. So this is huge. But below, this seems to be like a layer 2. So literally these opcodes, I think on their pricing, so you can check out on that page and look if you want to do address, or wherever you do balance of you're spending 700 in gas, calling get the call address to. So this can also help you to really maximize your smart contract. You know which to use in case of which. So maybe like instead of using require, you use revert, just based on opcodes. We can go to gas limits. Now you can imagine that there exists a lot of functions that are much more complicated than just sending if we have seen some. So for such functions, it can be hard to predict exactly the amount of gas that will be required for execution, as it depends on other variables. As such, instead of specifying the exact gas costs when deciding how much fees to pay for the transaction, you can specify an upper bound or a lower bound limit, like a range. So this is done like in many places, even during as you deploy. So here you always specify the amount of weight. If you don't specify, like for gas, the default amount of gas is 300. Is it 1, 2, 3? 1, 2, 3 million weight. Yes. So by this default, it means that at least this will be needed to do the transaction, and the remaining shall be returned to the wallet address, the deploying wallet address. That's why at least we take an upper bound, because if you have a lower bound, maybe if you specify gas that is lower than what the contract required, then the contract will be reverted, so it will not be deployed, and the gas used will not be returned. The gas used during the transaction. So transaction is either deployed or it reverts, but the work done and that gas is lost, that gas fee. So there are many other things. There is something like what we call block gas limits. So in addition to user-specified gas limits per transaction, the Ethereum network also imposes a limit on the maximum amount of gas what I mean by gas allowed in a single block. This ensures that each block stays within an allowable range of computation cost. So I heard you talking about computation cost. I think this is what we are looking at. So since more complex transactions take longer to execute, this makes sure that nodes don't start failing out of sync with the rest of the network due to increased computation complexity. So there are some scenarios where we saw the Solana blockchain like halting. This could be one of the things. Sometimes you send a transaction and it fails to go through because there is a lot of congestion in the network and the block limit has been reached. So only those transactions that have high incentivization are allowed through by the miners. So because of many of these issues, and for Ethereum pre-London upgrade, there was a very big issue with blocks because blocks were static. They could only accommodate 15 million of gas transaction in gas. Wherever 15 million of transaction in gas was reached, then a new block could be forged. And you could find that probably there are very many people transacting, and that's why initially the gas fee was really very, very high on Ethereum network. So we can briefly look at the post-London upgrade. So the London upgrade was implemented on August 5th, 2021. Yeah, and the reason for its implementation was better gas fee estimations. Quicker transaction inclusion, and then buying of percentage of transaction fees. Being used for transactions. So these were the major three issues as to why the London upgrade was implemented, and there were 5 EIPs, improvement proposals, but there was one major, and I think it is EIP 1155. But yes, that's research to work on. So starting with the London upgrade, every block was said to have a base gas price. So prior to the London upgrade, wallets like MetaMask would provide an estimate of gas price based on the past network activity of the blocks, and then they would aggregate probably the last 1,000 blocks that was for Ethereum to know the estimate gas that you would need. But post London upgrade, every block was said to have a base gas price fee. This was the minimum price per unit of gas for getting your transaction included within a block. So the network calculated this natively based on the demand of the block space, and the base fees would go to be burnt by the Ethereum network, and that really got rid of the ETH to offset issuance. You know that one of the things about it is it doesn't have a maximum supply. So in order to make it deflationary, most of the gas fee that went into transaction fee was burnt. Unlike a Bitcoin which has a maximum supply of 21 million, which will have a maximum supply of 21 million tokens. So Ethereum tokens can be issued anytime to the system. So to really counteract this, they have to find a burning mechanism to keep its value growing. So in addition to the base fees, of course, the concept of tipping, which is priority fees, was introduced. So the base fees got burnt, the tip was there to compensate miners. So you see that option of speed up your transaction, it is to compensate those that are mining. Yeah, higher tip transactions tend to get higher priority. Yeah, so with the upgrade, the formula to calculate the gas fees changed to this. I think we can do some work around it. So yes, post upgrade, this was the cost of gas fees. I really didn't want to go beyond 8. Okay. So we can have an example, and then you people can do that calculation. So probably using the first example that we had, I think so from this calculate the new value. I think we can take that one as the example. I will not wait for you this time. Yeah, I could calculate and then we shall look at the answer. So let's continue on this and have a finish around really seeing a lot of work, but you can go through it just and then complete it. So prior to that, we had a constant block size. I don't know whether this is what Emma was talking about. So post London upgrade, the concept of variable block size was introduced. We said as long as pre-London upgrade or before London upgrade, as long as the block size contained transactions that were worth 15 million of gas, then a new block could be proposed. But then post London upgrade, the upgrade introduced variable size blocks to Ethereum. Each block now has a target gas limit of 15 million gas, but the size can increase or decrease along with network demands up until a maximum of 30 million gas. So that means that okay, so here this is a variable, so the range is within 15 million to 30 million. So there is that elasticity of the block increasing to 30 million of gas. That was introduced after the London upgrade in 2021. So if the block gas is greater than the 15 million target, the base fees for the next block is increased. Similarly, if the block gas is smaller than the 15 million target, the base fees for the next block is decreased. The amount by which the base fees gets adjusted is dependent on how far the block gas was from the 15 million target. So that's a very, very strong thing. I think there's an illustration. Hopefully have it here. So is this illustration visible? Hope it is. So here there is a block number. So you can see that if a block, if the transactions a block are reaching the 30 million point, if they reach the 30 million point mark, in addition will increase the gas price by 12%, and this is a compounding increase. So you'll find out that this has, by the time you are just having 7 blocks away, you've compounded up. So this is 12.5% of this. This will not be 12.5% of 100, but 12.5% of this. So this is like a precaution that will resist people from, just including more blocks on the chain. I feel the concept of gas has many other things, but I'd love to wind up at 20 because I know that the EVM is also something that is huge. So I want to encourage us to go and research more about gas price. It would really improve the way we write smart contracts, the way we see gas, and maybe audit or build our projects generally. Any questions? So some of the topics maybe I would have talked about is why does gas exist? But we know very well it is one of the precautions, but it is also a utility. So for functions that have an infinite loop, gas is one of the mechanisms to make sure that your transaction stops as soon as your gas fee are depleted from your wallet. Any questions? Since there are no more questions, allow me to end with this topic. I see people are getting very tired. So, yes, the topic is reducing gas fees. One of the things we saw clearly is that Ethereum is very cost consuming. So what has it looked at to really reduce gas fees? In the first place, why is Ethereum's gas cost very high? So high fees on Ethereum is really a hot topic these days. So the Ethereum community has, so not to hurt the decentralization or security of the network. So as such a trade-off, so everything has a trade-off. One of the cores of Ethereum is its security and decentralization. So they have traded off, of course, things to do with scalability, which works with the transactions. So as as part of the trade-offs in favor of security, Ethereum network currently having higher transaction fees than other blockchains such as Solana, which Ethereum would want to have like those high transaction fees such as on Solana, which also has made trade-offs in favor of lower fees at the expense of security and decentralization. But the way Ethereum has chosen to go around this route is that it has led to introduction of new upgrades. We saw an upgrade in 2023 that totally pulled Ethereum, I think, off from proof of work to proof of stake. But we have also seen Ethereum supporting layer 2s, and that's how layer 2s came about. So when you look at most of the layer 2s, really, they have small transaction fees, and this is because they create mechanisms to bundle very many transactions on their own networks and then bundle it into one, which is called actually rolling up into one transaction that then they pass on to the Ethereum network to be verified as the right transaction. So Ethereum has highly invested in these layer 2s to ensure that they maintain the security and decentralization while keeping the gas fees. So I think with that, I can leave you to go and research about probably layer 2 scaling, the London upgrade, maybe Ethereum gas. You can search on videos about it. And yes, have a great time. Any questions? Yes.
Thank you for that session. It has been great. I'm inquiring whether we should do the calculation based on the first example that you gave, using the same values.
Yes. Should use the same values. All right. Have a great time.